Imagine a world where electricity suddenly disappears. No lights, no internet, no hospitals, no factories. Within minutes, modern civilization would begin to collapse. Yet most people use electricity every day without ever knowing what it really is or how it's made. Today, we're going to uncover one of the greatest engineering achievements in human history. What is electricity and how is it generated? Let's find out. Have you ever wondered what happens when you flip a light switch? In less than a second, electricity travels through wires and powers your lights, television, computer, or phone charger. But what exactly is electricity? Where does it come from? And how is it generated before it reaches our homes? In this video, we'll answer all of these questions in a simple and easy to understand way. By the end of this video, you'll understand the basic principles of electricity and how power plants generate the energy we use every day. Let's get started. Electricity is a form of energy created by the movement of tiny particles called electrons. Everything around us is made of atoms. Every atom has three main particles: protons, which have a positive charge, neutrons, which have no electrical charge, and electrons, which have a negative charge. The electrons move around the nucleus of the atom. In some materials, especially metals like copper and aluminum, some electrons can move freely. These free electrons are what make electricity possible. When many electrons begin moving in the same direction through a conductor, we call that movement an electric current. So, electricity is simply the flow of electrons through a conductor. Without moving electrons, there is no electric current. Electrons do not move on their own. They need a force to push them. That force is called voltage. Voltage is the difference in electrical potential between 2 points. A simple way to understand this is by thinking about water flowing through a pipe. Water flows because there is pressure. In an electrical circuit, electrons flow because there is voltage. The higher the voltage, the stronger the force pushing the electrons. Current is the actual movement of the electrons. Voltage is the force that makes them move. Both are necessary for electricity to do useful work. Now let's answer the most important question. How is electricity generated? The answer is surprisingly simple. Most electricity around the world is produced using generators. A generator is a machine that converts mechanical energy into electrical energy. Inside a generator, there is a coil of wire and a powerful magnetic field. When the coil rotates inside the magnetic field changes around the wire. This changing magnetic field forces electrons to move. As a result, electric current is produced. This principle is known as electromagnetic induction. It was discovered by the scientist Michael Faraday in the 19th century. Almost every large power station in the world uses this same principle. Whether the energy comes from water, steam, wind, or another source, the final step is almost always spinning a generator. Different power plants use different energy sources to rotate the generator. In a hydroelectric power plant, falling water spins a turbine. The turbine rotates the generator and produces electricity. In a thermal power plant, coal, natural gas, or oil is burned to heat water. The hot steam turns a turbine connected to the generator. In a wind power plant, moving air turns the blades of a wind turbine. The rotating blades drive the generator. In a nuclear power plant, heat from a nuclear reaction produces steam. The steam spins a turbine, which rotates the generator. Solar power plants work in two different ways. Some use photovoltaic panels that convert sunlight directly into electricity. Others use concentrated solar energy to produce steam that turns a turbine. Although these systems are different, their goal is the same: to produce electricity that can power our homes, businesses, and industries. After electricity is generated, it begins a long journey. First, transformers increase the voltage. High voltage allows electricity to travel long distances with less energy loss. The electricity then moves through high voltage transmission lines across cities and countries. Near your home, other transformers reduce the voltage to a safe level. Finally, electricity enters your house through distribution lines and powers your appliances, lights, and electronic devices. This entire process happens continuously, 24 hours a day. Let's quickly review what we learned today. Electricity is the movement of electrons through a conductor. Voltage provides the force that pushes those electrons. Most electricity is generated by spinning a generator inside a magnetic field. Different energy sources, including water, steam, wind, nuclear energy, and sunlight, can all be used to produce electricity. Finally, transformers and power lines deliver electricity safely to our homes. Thank you for watching. If you enjoyed this video and want to learn more about electrical engineering, electronics, and modern technology, don't forget to like this video, subscribe to the channel, and turn on notifications. See you in the next video.